Now let's take a problem based on method of section. Problem based on method of section. Method of section. So I am just drawing the given truss. This was the simply supported truss. This one is the simply supported truss. Here we are having two simple supports. I am drawing these simple supports, and now I am drawing the other members. These are the members of a truss, and now I am denoting the point, that is A, B, C, D, E, F, G, H. And here we are applying a force of 40 kilonewton. Here we are applying a force of 60 kilonewton. And here we are applying a force of 80 kilonewton. And this full distance we are having 4 at the rate of 3 meter. It will be 12 meter. So this one is the given simply supported truss, and now our interest in that problem to find force in BD, force in BE, and force in CE. Means we are interested in forces in few members. We are not interested in forces in full truss, means forces in each and every member of the given truss. So we know the method of joint is applicable where we have to find out forces in all the members, but in case of method of section, we are interested in force in the few members. Or we can say that if we want to find out forces only in a few members, then we have to go for method of section. By method of section, we can easily find out the forces in few members. So this is the given truss, and here I am saying this length BC is 3 meter, and this length is 4 meter, and again this one is 3 meter, and all these points are described here. So here we are interested in forcing BD, forcing B, forcing C. So first step, we have to find out reaction at the support, and we know the supports are the simple support, so reaction here will be RA and reaction here will be RH. So by applying the conditions of equilibrium, we can easily find out the reaction force. So here there is no horizontal force, so I will not apply the condition number 1, that is algebraic summation of all the horizontal forces should be 0. I will apply directly the condition number 2. Algebraic summation of all the vertical forces should be 0. For our sign convention, positive y is positive, negative y is negative. This is the y direction. So the RA and RH are acting in an upward direction. So we are having plus RA plus RH, that is in upward direction, and the 40 is in downward, so negative. 60 is in downward, so negative, and 80 it is in downward, so negative. It will be 0. So by this way we can write RA plus RH equals to 180 kilonewton. So this is the first equation we get from this equation. Now we can take the equation number 2, that is algebraic summation of moments of all the force about any point should be 0. So I am considering the point A here. So on A there is a reaction RA. So RA is passing through the A point, so perpendicular distance is 0, so moment will be 0. So I can write RA into 0. Similarly, due to this 40 kilonewton, here we are saying this distance is 4 at the rate of 3 meter. So all this distance are 3 meter. This is 3 meter, 3 meter, 3 meter, and 3 meter. So now if we take the moment due to this 40 kilonewton, we have to multiply it with this 3. So moment due to 40 kilonewton at A, it will be 40 into 3, and the direction of movement is clockwise. So our convention, clockwise is positive and anti-clockwise is negative. So we are in 40 plus 3. It is positive. Similarly, due to this 60 kilonewton, 60 we are having 3 plus 3, 6. And again clockwise, so 60 into 6, it is in clockwise direction, so positive. Again due to this 80 kilonewton, we are having 80 into perpendicular distance 3 plus 3 plus 3, that is 9. So 80 into 9, again in clockwise direction, so positive. And due to this RH, perpendicular distance is 3 plus 3 plus 3 plus 3, it is nothing but 12. So RH into 12, and the nature, it is anti-clockwise direction, so negative equals to 0. So now if we further simplify, that is 120, 360, 720, and this one is 12 RH equals to 0. If we sum 120, 360, 720, it will come 1200 minus 12 RH to 0. So RH will be 1200 divided by 12. So value of RH will be 100 kilonewton. So we got the value of RH, it is 100 kilonewton, and if we put RH in this equation, that is RA plus RH equals to 180. So RA will be 180 minus RH. So 180 minus 100, it will be 80 kilonewton. So by this way we can easily get the values of, I am again drawing the truss for our understanding. This is our given truss. Showing all these numbers. Simple support A, here H. We know the value of RH, that is 100 kilonewton. We know the value of RA, that is 80 kilonewton, and we know this distance is 3 meter. 3 meter. This one is also 3 meter, and this one is also 3 meter. And we know these points A, B, D, C, E, F, G, and H. And here we are having the force of 50 kilonewton. Here we are having the force of 60 kilonewton. And here we are having the force of 40 kilonewton. So now in method of section, we have to cut the section which will pass through 3 or less than 3 members. So now we are interested in the force BD, force BE, and force CE. So if we cut the section like that, then in a single cut we can know the forces in BD, BE, and CE. So before cutting the section, just know what is this angle theta. So if you see, this is 3 meter here, this full length is 3, so this one will be 3 meter, this one is 1 meter, and if you see this distance, this is 3 meter. So now we can easily find out the values of forces. Here we are having 3 meter, so this distance will be 3 square plus 1 square, so it will be root of 10. So we can easily find out cos theta, that is nothing but base upon perpendicular, hypotenuse base upon hypotenuse, and we can easily find out sin theta, that is perpendicular upon hypotenuse. So these are the values which will be useful in solving the mathematical equation. Now let's cut the section. Here I am cutting the section. This way I am cutting the section. And after cutting the section means how we can cut the section. First, the member should pass through 3 or less than 3 members. So here only 3 members are there, BD, BE and CE. And these members are our desired members where we have to find out the forces. So we are cutting according to our definition. We can cut the section like that, which will pass through 3 or less than 3 members. Now we can draw the free body diagram of a smaller part. So now we are drawing free body diagram of a smaller part. So in free body diagram of a smaller part, we are having this thing here, that is RA equals to 80 kilonewton we are having. Here we are having 40 kilonewton. This is the cut part here. This is also cut part, and this one is also B. So in the cut section we have to show the forces, and our assumption is forces are tensile, so it should be away from the joint. So it will be FBD. This one will be the FBE, and this one will be the FC. And this distances we know. This one is 3 meter. This one is 3 meter. And this distance also we know. This one is 3 meter. And this angle we also know. It is theta. So in terms of sine theta and cos theta, we know the values. Let's find the values of unknowns. So here, by seeing the diagram, we will use the conditions of equilibrium for solving the values of unknowns. So let's take condition like algebraic summation of moments of all the force above B should be 0. If we take the moment at B due to this FBD and FPE, so both line of action is passing through B, so the perpendicular distance will be 0. So we can say that moment will be 0. So I can write like FBD into 0 plus FBE into 0. Now takes the other two forces due to 80 kilonewton. Moment at B will be 80 kilonewton and this perpendicular distance. So I can write 80 into 3 perpendicular distance, and nature is in anti-clockwise direction. In clockwise direction. So according to our sign convention, it is positive. If we see the line of action of this 40 kilonewton, it is passing through B. So perpendicular distance will be 0. So I can write 40 into 0. And if I talk about moment due to this FCE at B, so FCE and perpendicular distance is 3. So it will be FCE into 3. And nature of this moment, it is in anti-clockwise direction. So it is negative equals to 0. I would like to repeat again. I am taking the algebraic summation of moments of all the force about B should be 0 as our equilibrium equation. So at B, FBD and FBE is passing through the point P. It means perpendicular distance is 0. So I am writing 0 here, 0 here. The moment will be 0. Due to 80 kilonewton, here it will be 80 and perpendicular distance is 3. So 80 into 3, and the moment is in clockwise direction. So it is positive. Due to 40 kilonewton, the line of action is passing through B, perpendicular distance is 0, so moment will be 40 into 0, that's 0. Due to this FCE, the perpendicular distance is 3, so FCE into 3, and direction is in anti-clockwise direction, it is negative. Now we can solve it. It is 240 equals to FCE into 3. So FCE equals to 240 by 3, it is 80 kilonewton. So we got the first force, that is FCE equals to 240 by 3 is to 80 kilonewton. Just some modify the free body diagram. Here if we extend the free body diagram, then we will get a point E. Right, so we can apply the condition number 2 at this point. Algebraic summation of moments of all the forces above E should be 0. And if we say E, and if we see the line of action of CE and BE, it is passing through E, it means perpendicular distance is 0, moment will be 0. So we can write FBE into 0, we can write FCE into 0. Now let's take the other forces. If I take this 40 kilonewton, so perpendicular distance from E is 3, so moment will be 40 into 3, and the direction it is in anti-clockwise direction, so it will be negative. Similarly, due to this 80 kilonewton, moment at E will be 80 into perpendicular distance 3 plus 3, that is 6, so 80 into 6, and the direction is in clockwise, so it will be positive. And if we see, the FBD is having two components, that is FBD cos theta in that direction and FBT sin theta in that direction. So moment due to FBD cos theta, it will be FBD cos theta in that direction into perpendicular distance, it is 3, and it is in clockwise direction, so it will be positive. Similarly, for sine component, here we are having FBD sine theta, and perpendicular distance is again 3, and the direction will be in clockwise direction, so it is positive. It should be, summation should be 0. So here we consider all forces, and now we will simplify it and then we will see. So it will be minus 120, that is 480, that is FBD cos theta, we know 3 by root 10 into 3, plus FBD sin theta is 1 by root 10 into 3 equals to 0. So now we will simplify 480 minus 120 will be 360, plus here we are having 9 FBD by root 10 plus 3 FBD by root 10 equals to 0. So now we are having 12 FBD by root 10 equals to minus 360. So FBD will be minus 30 into root 10 kilonewton. So this one will be the FBD. Now let's again draw the free body diagram of the smaller part. FBD of smaller part. So here we are having this FBD, that is 40 kilonewton. This one is 80 kilonewton, that is RA. Here we are having FBD. Here we are having FBE. This angle we know that is theta. Then this force we know that is FCE. And if we extend it, here we are having the point E. Here we are having point B. And this one is A. And this one is the point C. This distance we know, this one is 3 meter. This one is 3 meter. And this one is also 3 meter. So we can see this angle, that is will be 45 degree, because tan 45 is 1, so tan theta equals to 3 by 3, so it will be 45. So this angle will be the 45 degree. So now I am applying the condition One other condition, that is algebraic summation of all horizontal forces should be zero in horizontal direction or direction along x, that is positive x, that is negative x, and that is positive y, and this one is negative y. So we are applying the condition, that is algebraic summation of all the horizontal forces should be 0. So in horizontal direction there will be a component of FBD, that is FBD cos theta, and it will be in positive direction. So plus similarly the component of FBE in x direction, that is FB cos 45 degree, it is in positive direction, so positive. And we are having one more force, that is FC, it is in positive direction, so it is positive. And we know the value of FBD, it is nothing but minus 30 root 10. Cos theta we know, that is 3 by root 10. Similarly, we know we have to find out BE. Cos 45 we know, that is 1 by root 2. Similarly, FC we know, that is 80 Newton, kilonewton. So now if we simplify it, that is 90 plus 80 plus FBE by root 2. So we are having minus 10 plus FBE by root 2 equals to 0. So FBE will be 10 into root 2 kilonewton. So by this way we got the values of all unknowns like forces in member BD, VE and CE. And as our assumption, like we assume all the forces in the member of truss is tensile. So now we will see the sign, and according to that we will decide. So just to make a table for our better understanding, I am making a table here. This table will show the member, and here it is magnitude in kilonewton, and one more column we will add to show the nature. So we are interested in force in BD, BE and CE. So let's take BD. BD, the magnitude we are getting 30 root 10, and it is coming negative, so it is compressive. Similarly, the BE, we are getting the value 10 root 2 in kilonewton, and sign is positive, so it means it is tensile. For CE, we got 80 kilonewton, sign is positive, it means tensile. So by this example, we can easily understand how the method of section will work, and how fast we can calculate the values of unknown forces, or we can say that we can easily calculate forces in few members of the truss. So method of section is very useful if you have to find out forces in